Alright, so I'm making this video to go over some of the questions on the midterm. These are the midterms, or these are the questions where the class, less than 50% of the class got these right. So rather than write these out and just submit them as a PDF file, I want you to watch the video and just listen to the reasoning, how we get the answers. The first one I'd like to talk about is problem 5, which asks for the y-intercept of the line passing through these points 5, negative 5, 7, 3. Now, to find the y-intercept, we just want to find the equation. And to find the equation, we first have to find the slope. So we find the slope, it's rise over run, change in y divided by the change in x, and it's 4. Okay? So we'll have a line there where the slope is 4, that passes through one of these points, that passes through in particular 7, 3. So we can go ahead and find find the equation of the line. We get it's y equals 4x minus 25. Okay, it's in the form of y equals mx plus b, where b is negative 25. So that's the y-intercept. So the y-intercept is negative 25. The next problem I want to talk about is number 9. It's one of these conceptual problems. They talked about a vertical line. Well, how many times can a vertical line cross the graph of a function? And a lot of people were saying exactly once. The thing is that a vertical line might not intersect it at all. Look at this for example. Here's a graph of a function that's only defined where the domain is from negative 2 to 2. And we can clearly see that this would be a function, right? Because if we have exactly one y value for each x value. But we have certainly if we take a vertical line here, let's say at 3, that doesn't intersect it at all. Okay? So we say that the graph, a vertical line will intersect the graph at most once. Okay, not exactly once. That's the vertical line test. The next one was problem 16, where we're given that g is a function which is constant on the interval from 3 to 7. Okay, constant means that g of x1 equals g of x2 for all numbers x1 and x2 on that interval. Now you're asked, okay, what is g of? You're given that what g of 4 is. Well, 4 and 5 are both in this interval, right? So g of 4, it makes sense that g of 4 should equal g of 5. Okay, we already know that g of 4 is negative 1, so we get that g of 5 is negative 1. The next one is problem 21. And we've talked about this, I think, before in some of the videos and on a quiz. We can see that this graph is clearly decreasing from here to here and from here to here. What do we mean from here to here? Well, the interval is from 0 to infinity. So this is decreasing on 0 to infinity. Okay, it's also decreasing from negative infinity to 0, but this was the only option that was given. All right, for your first famous mathematician, I want you to keep it to write down. The name is Fermat. So that'll be the first one I'll ask you to write down, Fermat. Now let's go to problem 25. This was a piecewise defined function where we ask you to find the x-intercepts. To find the x-intercept, we usually say, okay, set y equals 0. Well, y is going to be f of x. So we set f of x equals 0. The only way f of x can be 0 is if one of these two expressions is 0. So we can set minus x plus 2 equals 0 and 3x equals 0. We solve this equation, we get x equals 2. Solve this equation, we get x equals 0. Now, we have to check that both of these inputs correspond to the right rules. Okay. In this first rule, we say that f of x equals minus x plus 2 only if the x value is less than or equal to 3. Well, 2 is less than or equal to 3, so that works. Next, 3x, f of x equals 3x only if x is bigger than 3. Well, 0 is not bigger than 3, so this doesn't work. So the only x-intercept is x equals 2. All right, so for number 26, and by the way, I should say you could draw the graph of this. You didn't have, I know you didn't have time on the test, but if you drew the graph of this, so you'd see that that would be the only intercept that you can see. Number 26, you're asked to find the domain of this function. And remember, with the domain, there are two rules. You can't take the square root of a negative number, and you can't divide by 0. And this is an example where you have to use both of those rules. Because first, when you see the square root, you see whatever is under the square root, that has to be greater than or equal to 0. Okay? So x has to be greater than or equal to 5. Okay? And some of you are saying, okay, well, this is the domain. The problem is you can't let 5 be in here because this square root is also a denominator. And if you try to compute g of 5, that's going to be 5 plus 1 over the square root of 5 minus 5, which is 5 plus 1 over the square root of 0. Well, what's the square root of 0? That's 0. And that is undefined, right? So that can't be. So we can't have x. X cannot be 5. So it's just the numbers that are strictly bigger than 5. That would be the domain. Okay. The average rate of change of this function, x squared plus 3, on this one, we talked about that. That's f of 5 minus f of 1 divided by 5 minus 1. Okay, that we had a formula for that, which you could have written down on your notes. All right, well, what's f of 5? F of 5 is going to be 5 squared plus 3, or 28. F of 1 is 1 squared plus 3, that's 4. So this is 28 minus 4 over 5 minus 1, which is 24 over 4, which is 6. All right. The next mathematician's name I'd like you to remember and write down is Euler. Okay. It looks like Euler, but it's really pronounced Euler. All right. So this next problem is 28. And this is another conceptual problem asked about local max, local mins. You had to graph y equals x squared plus 5 first. That, of course, took the graph of y equals x squared and shifted it up 5 units, so the graph looks like this. Obviously, there's no maximum. There is a minimum. So this point represents the local minimum. And I was asking for the x-coordinate. The coordinate of this point, the x-coordinate is 0, the y-coordinate is 5. So we have a local min at x equals 0. For problem 32, want to find the equation of the graph when this graph is reflected through the x-axis. Okay, you have to think about this. Reflecting through the x-axis, if you take a point and reflecting it through the x-axis, what y-coordinate, what coordinate are we changing the sign of? Well, this was up here, now it's down here. So the y-coordinate is changed, right? So you change the sign of the y-coordinate. Y in this case is 2x plus 3, right? So y is going, the new graph is going to be minus 2x plus 3. And of course we can distribute the minus sign. So yet y is equal to minus 2x minus 3. For 34, So point 1, 1 is on the graph of f. We wanted to find a point on the graph of y equals 3 times f of minus x. Here we had to do our transformations. We have to do we start with f of x, and we wanted to get something like this. First we're going to replace x with minus x, and then we multiply everything by 3. Okay. The point 1, 1 is on our original graph. We're changing the sign of x, so this becomes negative 1, 1. And then we're multiplying 3 on the outside, so we're multiplying the y-coordinate by 3. So this is negative 1. 1 times 3 is 3. Okay? And you can check that if you plug in negative 1 into here, you get 3. All right, 35 was the first of 3 problems from the last section on 2.6, section 2.6. And here you want to write the area as a function of x, where x is the width. You were given that this rectangle is 3 times as long as it is wide. So what does that say? Well, so in this case our w becomes x. We want to find the length. Well, the length is going to be 3 times the width. Okay? So the area is going to be 3x times x, or 3x squared. Okay? So that is the area in this case. So for the next one, 36, this time we're given the perimeter. We want to find the area where x is the length. We have to use the fact that we know what the perimeter is. We don't know what the width is. So if we call the width y, we know that 2x plus 2y is equal to 10. All right, now the whole thing is that we want to write the area as a function of x, which means we want to write y in terms of x. So we could solve for y in terms of x, divide by 2, and we get y as 5 minus x. So, all right, so then the area is x times y, which is now x times 5 minus x, which is 5x minus x squared, okay, which was one of the options. 37 was the last problem from section 2.6. We have a height of the cone. The height is twice the radius, so that means that h is 2 times r. We want everything in terms of h, so that means we want r in terms of h, so we get 1/2 h is equal to r, and then we substitute that in here. So the volume is pi over 3 times 1/2 h squared times h, which is pi over 12 h cubed. Finding the domain of this, okay, there's a lot of people struggled with this. Here we just remember whatever you're taking the square root of has to be greater than or equal to 0. Okay. So we can add x to both sides if we want. Okay. So x has to be less than or equal to 6, okay, which means negative infinity to 6, and we are including 6, right? All right, so we put the bracket there. Okay, so x. Right. And then finally, number 40, well, f of x equals negative 7x plus 8. Is this increasing on this interval true or false? Well, you could graph this, or you can just look at the slope. The slope is negative, right? So our graph, well, look, the y-intercept is 8. It's kind of irrelevant. The important thing is the slope is negative, right? So we can clearly see that this is decreasing. Okay, it's not increasing. So it's decreasing on negative infinity to infinity, so this is false. Okay. The last mathematician I want you to write down is Gauss. Okay. So write those three names and you will get some extra credit.